Hey, this is section 3.4. Today we're going to be solving equations with variables on both sides. When we finish, I want you to be able to solve linear equations that contain variables on both sides. I also want you to be able to determine if the equation has one solution, if it's an identity and has many solutions, or if it has no solution. So let's go through our steps to solve. They're going to be the exact same, the exception of rule number 2. We filled that in now. So we're going to simplify both sides. Okay, that means we're just going to combine our like terms. Now, for number 2, if there is a variable on both sides, we're going to check to see which one has the largest coefficient, and we're going to move the smaller one to the side that's got the bigger coefficient. Number 3, just like before, we're going to use our inverse operations to isolate the variable. 4, we're going to solve. Now if I have a solution, I'm going to end up with my variable equal to a number. But every once in a while I'm going to get something special. I may get a number equal to a number. And we'll talk about that in just a bit. So now let's look at a couple of examples. So I have 7x plus 19 minus 2x, is equal to negative 2x plus 55. Well, first thing I'm going to do is I'm going to see if I can combine my like terms. I don't have any like terms on either side of the equal sign to combine. Now, I've got x on both sides of the equal sign. Which is larger, 7 or negative 2? Okay, so 7's larger. So I'm going to add 2x to both sides. Now 7x with 2x is going to give me 9x plus 19 is equal to 55. My goal is to get x by itself. I'm going to subtract 19 from both sides, so this is just like we've been doing. So I have 9x is equal to, let's see, 55 minus 19, that gives me 36. Divide both sides by 9. I'm using the inverse operation because it's 9 times x. So I have x is equal to 4. Now I could check this real quick by saying, okay, plug 4 in. 7 times 4, okay, that's 28, plus 19 is equal to, let's see, negative 2 times positive 4, that's negative 8, plus 55. When I combine these together, I get 47 is equal to 47. So this answer does check out. Now I'd like for you to do the next one. So go ahead and hit pause and then restart when you're finished. Okay, so let's take a look at this one. So we're going to add 9y to both sides. So we have 80 is equal to 15y. Divide both sides by 15. 80 divided by 15. Let's see, 5 will go into both of those. So when I simplify, I get 16 over 3 is equal to y. Now let's spend a second, let's talk about what an identity is. An identity is an equation that is true for all values of the variable. So when we talk about an identity, I'm comparing the exact same things together. So if I were to solve this, let's see, I'm going to use our trick that we talked about earlier. Let's see, we're going to distribute. So I get 3x plus 6 is equal to 3x plus 6. I have the exact same thing equal to the exact same thing. So I automatically know when I see that I'm dealing with same lines and I'm going to have an identity. Well, I'm going to subtract 3x from both sides. Now what's 3x minus 3x? Well, that adds up to 0. So I end up with 6 is equal to 6. Is that true? Oh, when I get the same number equal to the same number, it's true and I have an identity. What's actually happening here is I have the exact same line. So no matter what number I choose, it's going to work. So let's take a look at that. So let's say I had 3x, 3 times x plus 2 is equal to 3x plus 6. Let's see what happens if I plug in, I don't know, let's plug in the number 2. So I'm going to let x equal 2, and let's see what happens. Well, 3 times 2 plus 2 is equal to 3 times 2 plus 6. Well, 2 plus 2 is 4. 3 times 4 is 12. 3 times 2 is 6. 6 plus 6 is 12. Any number that you choose to plug in for x is going to give you a true statement. And we're going to be talking a little bit more about that later. So now let's take a look at 4 times x minus 5 is equal to 4x minus 20. I want you to go ahead and hit pause and work this one. Okay, when we worked this one, we distributed the 4. I had 4x minus 20 is equal to 4x minus 20. So now the rest of this is just kind of going through the motion so that I can get my final number equal to a number. Subtracted 4x from each side. 4 minus 4x gives me 0, leaving me with negative 20 is equal to negative 20. As soon as I see that, I know that I have an identity. Okay, let's take a look at another one. X plus 2 is equal to x plus 4. Well, I see I don't have the exact same thing equal to the exact same thing, so I know I don't have an identity. Although sometimes that identity will be camouflaged and it'll be a little harder to spot. So we're going to subtract x from both sides because we've got to have our variables on one side of the equal sign. Well, x minus x leaves me with 0. Well, now this is weird. Now I've got 2 is equal to 4. Are 2 and 4 the same number? No. So this doesn't make sense. I can't have that. That tells me that I have no solution. In a chapter we're going to work at a little bit later, we're going to come to realize that that means that we have parallel lines. So there's absolutely no way that these equations could intersect. Okay, now once again, go ahead and hit pause so you can do the next one. Okay, now when we do this one, I want to make sure that you distributed 2 times x and got 2x, and 2 times 3 and got positive 6 over here. Subtract your 2x from both sides, leaving you with 3 is equal to 6. Does that make sense? No. No sense. No solution. Okay, let's work on another one. So let's go ahead and distribute so we can combine our like terms and get this guy simplified. So I have 4 times 1 gives me 4. 4 times negative x is negative 4x plus 3x is equal to negative 2x minus 2. I'm going to simplify both sides of my equation. Negative 4x combined with positive 3x leaves me with negative x, so I have 4 minus 1x is equal to negative 2x minus 2. Now I'm going to look at the coefficient of both of my variables, so I've got negative 1x and negative 2x. Which number is larger, negative 1 or negative 2? Oh, negative 1 is larger. So I'm going to add 2x to both sides. So now I have 4. Negative 1x plus 2x gives me plus 1x. Adds up to 0 is equal to negative 2. Still want to get x by itself. Who's in the way? 4. I'm going to subtract 4 from both sides. So x is equal to negative 6. Okay, now look at this one. Don't let the fraction upset you. So I want you to go ahead and hit pause. This is the last problem. Distribute that. I want you to notice what's going to happen. 12x over 4, 16 over 4, those are going to simplify. So just because it has a fraction, don't let it bother you. So go ahead and hit pause and then resume when you're done. Okay, so let's go ahead and distribute. Work through this. So we're going to get, numerator times numerator gives me 12x divided by 4. Well, 12 divided by 4 is 3. That gives me 3x. Numerator times numerator gives me 16. 16 divided by 4, which is my denominator, plus 4, is equal to 10. Now I've got to distribute a negative 3. What's negative 3 times x? Negative 3x. Negative 3 times negative 2. Positive 6. Most common mistake are the signs on this section right here. So let's see, which is larger, positive 3 or negative 3? Positive 3, so I'm going to add 3x to both sides. Now this is a problem that my people who like to work everything in their head have a little trouble with, because they say 3x minus 3x minus 3x is 0 and I'm done. But I've got to use my inverse operation over here. So now I have 6x plus 4 is equal to, what's 10 plus 6? It's equal to 16. I'm going to subtract 4 from both sides. So 6x is equal to 12. Divide both sides by 6. And x is equal to 2. And that's all we have.